Hey Becca, what are we learning today?
Today, we will be finding the range of a function. The range of a function is all possible values that can be outputted from the function. Let's look at a simple function, y equals x. If we graph this function, we just get a diagonal line that goes through the origin and has a positive slope. If x can be any value, we look on the x-axis and we can see that x can be any positive value or any negative value. Then if we look at the values for y can be all possible values as well. So the range of this function y equals x is simply all real numbers. And interval notation, negative infinity to positive infinity in parentheses. Let's look at an example. Y equals 1 over x plus 2. If we graph this function, it's a hyperbola with a horizontal shift, -2, we have a vertical asymptote, and we have a horizontal asymptote at 0. And then we draw our hyperbola. You can also graph this function with a graphing calculator. So, let's figure out what y values can be outputted from this function if we plug in any x value. If you look at the y values on this half of the graph, we're covering every positive y from 0 all the way up to infinity, but we're not including 0 because 0 is a horizontal asymptote. So we've got all of the positive numbers covered, and then if you look at the left half of the graph, all of the negative y values, if you look at the y-axis, are hit by this part of the function. So we've got all of the negative values covered, but the function never crosses the x-axis. Note that horizontal asymptote. So that means that y will never equal 0. And that is our range. If we write that in interval notation, the range is negative infinity all the way up to 0, end parenthesis because we're not including 0, and we're going to union that with the positive side, which is 0 through positive infinity. Again, not including that 0. Now note that if you have a fractional function, y equals a over b, if there is no x in the numerator of this fraction, then y will never be able to equal 0. If no x in numerator. Now let me show you an example. Y equals 1 over 2x squared plus 5. Y can only equal 0 if the numerator equals 0. But will this 1 ever equal 0 regardless of what we plug in for x? No, this 1 will never turn into a 0. So in this case, y will never equal 0, and we've already found our range. And in interval notation, similar to the last problem that we did, this is going to go from negative infinity to 0, not including, union 0 through infinity. So 0 is the only value that's never going to be a solution to this function. Here's a simple example. Y equals 3. we want to find the range of this function. When you have y equal to a constant, it's just a horizontal line at that constant value, which is 3. So I'm going to draw this horizontal line on the coordinate plane, and that's our function. Now, can y ever equal 2? This function is never going to hit the line at 2. What about at -4? This function will never hit -4. The only thing that y can ever equal is 3. So y equals 3 is itself the domain of this function. And if we're going to write this in interval notation, we're just writing the point that y is in, and y can only equal 3 in this case. Now we're going to find the range of a parabola. Y equals x squared plus 2. If we're to graph this parabola, this is just a parabola shifted up 2 points, has a vertical shift, and it's a positive parabola because the a value in front of the x is positive. So now let's look at the y values that come out of this parabola. When x equals 0, y equals 2. That's where the vertex is. When x is positive or greater than 0, where does y go? Y increases from that vertex. So y is greater than 2. When x gets greater than 0, y gets bigger. And then when x is less than 0, so when we have negative values for x, what's happening to y? It's also getting bigger because a parabola is mirrored on both sides, so y is also greater than 2 when x is less than 0. So, if we look at our chart of values here, y equals 2, y greater than 2, y greater than 2, y will never be less than 2. So in order to find our range, we say that y will only take on a value of 2 or greater, and then in interval notation, we have a bracket on the left side because we're including the 2 all the way through infinity with a parenthesis. I have one more example to go through today. Y equals 5 to the x. This is an exponential function, and if we draw just a rough sketch of it, it's going to look something like this. So now let's look at this function here. Look at the y values that are coming out of this function. The y values are the ones that are going to hit when I do the horizontal line test here. As I move up the y-axis, all of these positive values will be hit, especially because this line continues to get bigger and bigger. So we know that positive infinity is going to be our end point to the range. But if we look at the function 5 to the x, no matter what value we plug in for x, this function is never going to hit 0, and it's also always going to be greater than 0. We can never get an exponential function with a base of 5 to be negative, no matter what we plug in for x. If we plug in a big number, positive number, we're going to get a positive number. If we plug in 0, we're going to get 1. And if we plug in a negative number, we're going to get 1 over 5 to the positive 10, which is a very small number, but it's still positive. We're never going to hit 0, and we're never going to be less than 0. So we're always going to be greater than 0. So if we're going to write our range, we're going from 0, not including, all the way to infinity. Thanks for watching my video on finding the range. If you have any questions, make sure you leave them in the comments or send me an email. And if you like this video, make sure you subscribe and stay tuned because I'm posting new videos every Monday and Thursday.